Yeah, in my view, I can see in 2030 perhaps that we will have a fleet of drones that lives in the wind park, and you can just fly out and you can do your inspection and perhaps even small repairs.
Offshore wind energy is an essential part of the successful energy transition in the Netherlands and should grow enormously in the coming years. Various projects are taking place within the programme of TKI Wind op Zee. This also includes a project in which many innovations are developed, tested and demonstrated called AIRTuB. This video focuses on the part that aims to automate the inspection and repair of turbine blades.
Offshore wind turbines get bigger and bigger, and the parks are further and further out offshore. And it's very complicated. You have to have a couple of people on the site, one safety guy, one or two climbers, and you need a boat to get them there. You need a weather window. Perhaps the wind farm is 25 kilometers offshore. So we need to think of automated ways of inspecting and repairing wind turbine blades. I'm Jeroen Verschelling and I'm a technical project manager at World Class Maintenance. The aim of the project is to develop several different solutions for inspection and repair of blades for offshore wind turbines. So for inspection, we develop a laser line scanner that is flown under a drone along the leading edge of the blade, and it inspects the blade edge for erosion. And secondly, we develop a crawler that can land on the blade and can crawl across the blade and look inside with an ultrasonic sensor for damage.
Our part is to let the drone navigate itself towards the wind turbine, localize the turbine, localize the position of the blade, and then tell the UAV, well, you need to go to this certain point in the real world where the blade will be, and we will be assisting the drone with how much distance there is between the drone and the blade itself. I'm Fedor Ester, Managing Director of Demcon Unmanned Systems. So the laser scanner, the 360 LiDAR, makes a model of the wind turbine and the blade, and then a very accurate point cloud of this object. And then it can determine itself very accurate in front of the object itself, and it knows its position. And that enables the drone to fly very close to the blade with a lot of safety.
It's quite a challenge to get the drone so close to the blade that you can do the inspection. We need to be 1 meter from the blade. But we don't want to hit the blade, of course, with a 40-kilo drone. So we have to fly very carefully at 1 meter distance from the blade along the leading edge of the blade. So the leading edge is the front part of the blade. That's where the blade hits the wind first. And when it gets eroded, you get all kinds of little holes there. And that determines the aerodynamic performance of the blade, so it will decrease because of this erosion. And one of our partners in the project, Q-Layers, has developed a solution for that.
So for the AIRTuB project, we developed a head that can actually apply transitions between leading edge protection tape and the wind turbine blade itself. I'm Ruben Geurtjens, the CTO and co-founder of Q-Layers. So as the wind turbines are getting longer and longer, the speeds at the tips of these wind turbines, they also get higher. You have to think about speeds between 500 and 600 kilometers per hour. And from the moment a raindrop impacts on the surface, it hits away material because it impacts like a bullet. So part of the solution that is already common in industry is the use of tapes. It's called leading edge protection tape. And these tapes, they are quite thick. They have to be protective. But that also causes disturbance in the airflow, which makes the wind turbine also less efficient compared to having a wind turbine without the leading edge protection. So the specific technology that we developed is a coating application head. It's essentially a head that makes the transition from the leading edge protection to the blade. And we do this by applying the coating in a wet stage. And while we're moving over the surface, we're curing the coating in place. So once the head passed over the surface, you have a hard or a cured layer behind the head, and that's directly the finished layer.
So we have a whole roadmap. It's actually a program. And this is the first project. The development of an autonomous inspection vehicle is the first part. And the next step is to develop a resident system that can live and reside in the wind farm.
Are you also working on an innovation? And would you like to know what TKI Wind can do for you? Please contact us.